Hi, today we're going to be talking about linear regression. Linear regression is a sophisticated statistical procedure for finding a fit for some nonlinear data that's kind of scattered about. It doesn't all fall in a line, but we'd like to approximate the data with a line. Now, we're going to use the linreg function on our calculator, so you're going to need your TI-83 calculator. So let's get started with an example. So gross domestic product, GDP, is a measure of all of the final goods and services produced by a country. And so, here are some data. In the year 1980, the gross domestic product was 2.8 trillion for the United States. In 2010, that's 30 years past 1980, the gross domestic product was 14.7 trillion. Now this data is scattered about. It doesn't fall all on a single line. But what we'd like to do is find a model, something to represent this data that would allow us to predict what's going to happen in the future, perhaps, like what's going to happen in 2014 out of this data, or in our case, 2018, 2019. What's going to happen in the future, given that it would continue along this trend? So let's start, get out our calculator. We got to get the data in our calculator. So this is the TI-83, and so the first button we're going to hit is the stat button here, right in the middle, stat, and there's a menu here. We're going to hit edit, so edit number one. Just hit number one on your calculator, and you'll get the list menu here. So we got this data, and we're going to put in their data. So we're going to put in the L1 the X data. The number of years past 1980. So 0, 5, 10, 15, 20, 25, 30. So we're putting in the smaller numbers. We could use the dates, but in this case, it's a little better if we use a smaller number. It's a little less sensitive to changes. And then in the L2 slot, we put in our gross domestic product numbers, 2.8, 4.2. We don't put in the million. If it gets too big, we have some problems with our calculator. So we want to put in the without the trillions of dollars in there. 14.7 trillion is the 2010 data. All right, once we got the data in there, what we're going to do is, we need to compute what's called correlation along with our model. Now, correlation is a fancy statistical term, but in order to get our correlation value, we need to turn diagnostic on. It's in our catalog menu, so if you do a second function 0, go to the catalog, you're going to see a list starting in the A's. If you hit the X inverse button, it'll actually get you down into the D's, and you just keep scrolling down until you find diagnostic on. You're going to hit diagnostic on, you're going to hit it twice, and you're going to turn it on. Okay, once we're there, we're going to hit stat again. Hitting stat, we got what's called the calc menu, so we're going to move over with our arrow. We were in the edit menu, now we're in the calc menu. So in the calc menu, we're going to go down to number 4. Now you can just hit number 4 on your calculator, and it'll do it. It'll pull it up, and you're going to hit enter again. And here is the model of our data. So y equals ax plus b. It's telling us the slope is a, is 0.405, and we have a y-intercept of 2.139. And now this other stuff, r squared and r, are some statistical ways of analyzing this data. How good is our data approximating, how good is our model approximating this data? Now, correlation, let me just give you a little bit more information. We represent it with the letter R. It measures the strength of the linear association of the data. So data that falls on a line exactly would actually have a correlation value of 1 or -1. The sign of the correlation coefficient actually goes with the slope of the data. So if the data has a negative trend, the correlation value is going to have a negative slope. If the data has a positive trend, the correlation value is going to be positive. But the correlation value is not equal to the slope. It just has the same sign. Now, the correlation value is always between -1 and 1, or it could be 1 or -1. If it falls exactly at -1 or 1, it's on a line. If it's close to -1 or 1, it's close to a line. It's a very strong association. It's a very strong linear association. If our correlation value is close to 0, then our correlation value is low, and we have a very weak linear association. So let's go a little farther here. So we ran our model. We got a slope of 0.405. We got a y-intercept of 2.13 and a correlation value of 0.993. Now we're going to want to hit the y equals button and put that line into the calculator. Now you can actually just type it, just write down on a piece of paper what the slope was and what the y-intercept was, and then type it in there. Now you want to use all the digits of precision here, so we all get the same answer. So we don't want to do a lot of rounding off at this point. So here is, this is in our Y1 menu. And we have our data in. Now I had to actually turn stat plot on. So these are a few little features that you need to work with your instructor on if you're having a little trouble. So turn on your stat plot 1, make sure it's on. And then we're going to hit zoom stat, and we get this nice little picture. So the data is, the line there is our model. The data are actually these little dots along the line here. So you can see that some are a little off and some are right on. And this is a really good model of this data. It's a strong correlation because it's close to 1, strong correlation value. Now let's look at our data one more time. So this is our original data along this line. Now if you hit trace and hit the down arrow, you can get on the model. The model is Y1 and the data is like a L1, L2 comma in the upper corner. So make sure you hit the down arrow and get on the line. So now you can move along the model and predict other values. So we've graphed it, and now we'd like to predict the GDP in 2014. So 2014, let me just point out that 2014, that would be 34 years past 1980. So we're talking about 34. And so what is that? What are we suggesting is the GDP going to be in 2014 and given this trend continuing? And the answer is about $15.9 trillion. And so you can see it on the calculator is the Y value there. Now you're going to have to actually change your window to include 34 in your window. When you do that zoom stat, it's going to keep the window trapped between 0 and 30. So you're going to have to expand your window to include 34 before you hit trace and type in the value. So that's how you use linear regression to model a set of data and use it to predict a future value. Thank you so much.